Okay, so this next video is all about resistance. So with this one, we're going to be talking about resistance in terms of what is it and how we can calculate it. And there's a few other videos about resistance as well, including Ohm's law and the factors factors that affect resistance. So when we talk about resistance, it's not actually a physical thing, okay? It's the way that we describe, okay, how difficult it is for current to flow through a circuit, okay? So resistance is often defined as kind of the opposition to current, okay, or it opposes current. Okay, so we can calculate that as a value. All right, so basically it's how difficult it is for current to flow. So if we have a really high resistance, we have a really low current. Remember, current, we use the letter I to represent it. Okay, if we have a really low resistance, sorry, I'm going to put I in there again. If we have a really low resistance, we're going to have a really high current. So a high resistance means we have a low current. It's really hard for current to flow through, whereas a low resistance means we have really high current. So what we have to think about then is the structure of our wire. So our wires are made up of metal. Okay, so we have a metallic structure going in. So we have positive ions. Okay, we have a lattice of positive ions. Okay, so remember lattice and ions being key words here, not lettuce. Okay, and we have free, or we could say delocalized electrons. Okay, and so for current, remember, current is the flow of these electrons moving through this circuit. Okay, so there's free electrons that are free to move, and remember these little positive ions are just vibrating around a fixed point. Okay, so how easy or difficult it is for these electrons to flow through is really what I'm talking about when we're talking about resistance, and we can measure this, all right? We'll talk about some factors that affect this. We're going to look at heat, we'll look at cross-sectional area, we'll look at material, and we'll look at length, but that again was in another video, which you'll see a few below. So if we're trying to calculate resistance, okay, resistance we can calculate using R is equal to V over I. Now, often people don't remember it that way. Often people just remember that V is equal to IR, and we sort of say V. Okay, so we can have V is equal to IR, which if we rearrange gives me R is equal to V over I. And just to make sure we've done the third one, can't miss current out. So I is equal to V divided by R. Okay, so if we're looking at that in this way. So if I'm looking at resistance, it's the voltage divided by the current. Okay, so if I want to give this as a triangle, I've got V and then I and R. So these, remember, are divide, and this is a multiply. So R is resistance. V is our voltage. Okay, we can also call that potential difference. And I is our current. Okay, voltage should always be measured in volts. Okay, so that's with a V. Current should be measured in amps or amperes. Remember, that's A. And our resistance, okay, this is measured in ohms. Now, ohms is given by this little formula, this little symbol here, which is an omega sign. So that's the Greek symbol for omega. So I often think it looks like two little feet with almost like a little kind of little half circle kind of set on top. So it's like you're almost forming like a little circle, almost like a little balloon with two little feet, and that's your omega sign. Okay, so you can also think ohm, omega, okay, to kind of get your symbol for that. So we're going to do a little practice question. So if I asked you, what is the resistance of a circuit that's connected to a 12-volt battery that allows a 2-amp current to flow through it? Okay, so what's the resistance of a circuit if we have a 12-volt battery and it's allowing a 2-amp current to flow through it? So in this case, I need to write down, first of all, showing my equation. So in this case, I want to work out what resistance is. So that's V divided by I. So I'm going to say R is equal to V over I. And then I'm going to plug in my value. So I'm going to do my 12 volts divided by 2 amps. I don't need to change any symbols here. They're in volts and amps already, so I don't need to convert any units. So in this case, 12 divided by 2 is just going to give me 6. But remember, I need to make sure I always give my units, so I'm going to give my omega sign, so it's 6 ohms. So that would be my answer there for resistance, okay? So resistance, just to kind of summarize, it's what opposes current, okay? So it's the measurement of how hard it is for current to go through. We measure it in ohms, and we can calculate it by using the equation V divided by I, okay? And that was resistance.